Okay, let me start recording. Okay, so now let's start, okay. So yeah, before we go on, let's discuss here. Okay, so basically, let's say you want to communicate between host H1 and H4, right? This is VLAN 11 and this is VLAN 12. Okay, so you have VLAN 11 here and VLAN 12 SVI here, right? You don't have, just forget about this. You don't have both SVIs at basically 12 here and 11 here, right? So basically what you have to do is you have to use common WAF, right? Let's say one WAF A, okay? WAF A and with some VNI 111, okay? Now what you will do is you will route the traffic from, so basically this guy will send packet to the gateway, VLAN 11. You will route the traffic into this WAF, right? Now when you have to send that packet out, right? Can you tell me what will be the source MAC of inner packet, right? And destination MAC? So basically when you route the packet, right? Okay, so we can write down the full, so what will be the source IP, right? Source IP is this, right? If we have to write down the packet, correct? ICMP packet. So source IP will be 11.10. Destination IP is 12.11, right?
Mm-hmm.
What will be the source MAC and destination MAC? This is a inner packet, right? ICMP packet. What is the source MAC and destination MAC?
Source MAC would be R1.
R1 means this GTS, right?
Yes.
Okay. And what is the destination MAC?
R2.
R2. That is this guy, right?
Yes.
Can anyone tell me, or are all of anyone else has any different thought? Is this correct, or do you think it's different?
Is the ICMP packet of H1 or from R1?
ICMP between H1 to H4.
No, that then source MAC will be H1 and the gateway. Destination MAC will be the gateway.
So, but after it gets routed, it will be
After that, I think.
Yeah. So at this point, we are what we are writing is at this point here.
Oh, then that's fine.
Okay. Anyone else? So basically, point is, because your SVI 12 is not here locally, right? Basically, what you have to do is you have to route the packet to next stop of this, right? You can't learn or send the packet destination MAC as H4 because that is not directly connected. That subnet, right? This subnet is not directly connected here. So basically, you have to route the packet to this guy, and from here again it will be routed. You change the source MAC and destination MAC, right? So source MAC now here, when you send this out, source MAC will be R2 or TG501 MAC, and destination MAC is H4, right? Because now you have SVI 12. So you will learn RPN MAC locally, correct? So point is, irrespective of whatever all the host here where you want to send the traffic in VLAN 12, you don't have to learn this all MAC addresses here because SVI 12 is not present here, right? Only what you need to learn is the next hop MAC address, this MAC address, right? To forward the packet. Are you guys agree with me?
Yeah.
Anyone has any question? Or if you have not got understood? Okay. So yeah, so let's move on. So that's what we are doing here, right? So we are sending traffic to the gateway of IRB 100, right? IRB, this 200 is not present here. We will route into this WAF. Now when we send the encapsulated packet out, it will be like this, right? So your source IP is your this IP address, right? Server 12 IP address. Destination IP is 2223, correct? What is the source MAC? So source MAC is VTAP1 MAC, right? This MAC, because you have routed the traffic. So your MAC will change. Now this will be source MAC, and this VTAP2 MAC is the destination MAC. So this is the source MAC, this is the destination MAC, right? What is the VNI? VNI will be this blue VRF VNI, right? You have configured VXLAN VRF A, right? Whatever name VRF A and VNI 100, right? Sorry, 111. So this will be the VNI 111 or 2. Basically, it will be this VRF VNI. So not 200, it will be 111. Okay. And then source VTAP IP is VTAP1, destination IP is VTAP2, and then source MAC and destination. Okay. So this is how you will craft the packet and send it out to the other side. Okay. Any question? Okay. So basically the advantage here is that the limitation, right? Asymmetric had that you need to learn MAC addresses because you have SVI in asymmetric. Each VTAP has SVI for all the VLANs, right? And because you have directly connected route for all the VLAN, you will learn ARP and MAC address for all the end hosts, right? So if you have 100,000 hosts, 100K hosts, you will learn MAC address for all the hosts, right? On each VTAP. But here you don't need to learn MAC address of other hosts because you don't have that SVI. What you need to learn is only the MAC address of other VTAP, right? So if you have another VTAP 3 also here, you need to learn MAC address of this VTAP, and you have to just forward the packet to this MAC VTAP. And from there, it will take care of its local VLAN, right? Okay. So basically this limitation is solves in symmetric IRP. Okay. Any question?
Vishal, so
Yeah.
this we are talking from switch 1 to switch 2, right?
Yes.
So suppose if my switch 1 is an MLAC pair and switch 2 is also an MLAC pair, so now the source MAC of would be like
okay.
virtual MAC?
Virtual MAC is possible. See, let's say here and here both are virtual MAC is same, right? So what do you think? Which MAC should be there? That is very good question, right? Say this is MLAC pair, right? Which MAC we should use?
But if so in the MLAC we have the same VTAP IP, right?
Yes,
on both
that
of
is
them.
yes. VTAP IP is same.
So if we are talking,
so basically, yeah, we have to use MLAC system ID MAC, right?
Yeah.
Right. So basically, they when they do MLAC, bring the MLAC up, they decide one system ID which they will use for downstream neighbors, right?
Yeah, that's
which is common.
MAC, yeah.
Same MAC they will use for this also.
Yes. Okay. So destination will also be the MLAC MAC, right?
Yes, MLAC MAC.
Okay.
Now the question is how VTAP1 will know the MAC address of this guy, right? Because this is L3 link, correct? L3 and BOF. It's in between there are spine and all that, right? It's not direct, right? So how, VTAP1 now, as we discussed, right? VTAP1 has to, then it has to send the packet. It should know the destination MAC, basically VTAP2 MAC, right? Then only it will fill this information, right? So how it will know, right? VTAP1 will know what is the MAC at the VTAP2, right? So that we'll see in next slide. Okay. But is this clear?
Yes.
Okay. Perfect. So, yeah. Okay. Yeah. So basically, this is the reason why we have to use the system MAC of this guy, right? Destination MAC. because you don't have directly connected route or SVI 200 here, right? So basically you have to route the packet, right? And then it will be routed again here into VLAN 200. And that's why we can't use this MAC directly here, but we have to send packet to intermediate next hop, right? Now, so this is the difference of type 2 route, right? Type 2 route, if you compare this to, right? If you compare, this is asymmetric type 2 and this is symmetric IRB type 2, okay? And what you will see here is there are extra fields. So you have L3 VNI added here, right? In symmetric IRB type 2 route, right? You also have route target for IP WRF added. So you already have MAC WRF, right? But you have now another route target for IP WRF that is also added into your type 2 route field. And another is routers MAC extended community. This is the MAC of your route VTEP MAC, system MAC, right? Or MLAC system ID. So that is where what you will send also as a type 2 update, right? So basically, what are the information you are adding? So when you are sending the update message, right, from VTEP 1 to 2, when you send update message from VTEP 1 to 2, so for one thing you will add is the VNI, L3 VNI, okay? So that is this WRF VNI 111. You will add route target of this WRF, right? Maybe we have configured for this WRF. I'll show the config 1010, then you will add that 10:10 as well, right? Route target of that WRF, VNI of that WRF, right? And router MAC. So this system MAC, right? Whatever we are using between two MLAC pair, that MAC also we will advertise into type 2 update. So basically when type VTEP 2 receives the route, based on all this information, it will, populate the routing table where he knows what is the destination MAC, right? Because we are sending now in type 2 update. So basically it has now this destination MAC, VTEP 2, right? Knows about what is the destination MAC for VTEP 1. And it will, basically put that destination MAC. Okay. Is it clear? Any question?
Vishal, so the
Yeah.
type 2 route is sent like when we learn the MAC address, right? Locally.
Yes.
And then it sends a type 2 route. So in this case, since this is the system MAC for which we have to send the type 2 route, so when will this be triggered?
Okay.
This will
So, okay.
not
So see, okay. So see, okay, let me come back here, right? See, this type 2 route, when we advertise type 2 route, when we learn R for MAC, right?
Yeah, yeah.
And that's the so whenever you learn locally MAC or R, you will generate this, right? MAC and ARP information, right?
Mm-hmm. Mm-hmm.
So let's say this is your VTEP 1, right? VTEP 1. And this is host H1 in VLAN 100, right? 200 is not here. As soon as you learn this is part of this VLAN 100 is part of WRF A, okay? As soon as you learn this MAC and ARP here you will generate this type 2 route, okay?
Yeah. Mm-hmm.
So that is same as asymmetric. What is different is you have to add this other information as well into your type 2. So you are generating type 2 route only, right? For MAC or ARP you have learned.
Okay.
You will have this few more information. What is that? L3 VNI, right? That is 111. Route target for IP WRF, that is 10:10, right? And router MAC of this VTEP, whatever it is. Let's say router R1 or VTEP 1 MAC, right?
Okay.
So we are not sending this router MAC explicitly as a MAC update. Okay.
Okay. Okay.
We are including whatever route updates we are sending for ARP and MAC. We are including this into that field.
All right.
This is one field, one of the field into that update message.
Okay.
Is it
So
clear?
for every type 2 route, this would be included.
Yes, this fields will be included. Okay.
But yeah.
Anyone have any question? Okay. I'll show you the configuration so that you know it makes sense to you. So let me show you the config first, right? So that you get the idea. So this is our VTAP 1, so which is nothing but, if this is the topology, this leaf 1A, right? Leaf 1A. And we have host H1 and H2 connected to it, right? 10.1.10.101, right? So let's take this into 10.1.10.101. Okay. So I have the ping continuously running. Okay. So that we always have ARP updated. So if I do show ARP, okay, first let me show you the config, right? So show run interface VXLAN 1, right? VXLAN configuration. So VXLAN source interface loopback 1, right? Show run interface loopback 1. Yes. So this is your loopback IP address. Do you see any difference compared to normal VXLAN without EVPN?
Secondary
Yeah,
VTAP is not
secondary
configured.
loopback IP address is not there, right? So that is not needed, right? In EVPN. So that is one. Another is UDP port. We'll discuss about this later. Right now, you can just ignore that. VLAN to VNI mapping. So we have local VLAN 110 and 111. So we have 110, 111 here, and this side 112 and 113. Okay, two different VLANs. 110, 111, 112, 113. There is no overlap of VLANs. So yeah, we have VLAN to VNI mapping. We have one VRF, let's say tenant A. This is the VRF. So VRF A, VNI 10. So this is what our configuration is, right? We have this VRF A and VNI 10. Okay. So that is our intermediate VRF through which we will route the traffic, right? Forward the traffic. Now show run interface VLAN 110, right? So as this VLAN 110 is in which WAF? WAF A, right? So basically this VLANs, both VLANs are in WAF A, and same here, it's in WAF A, correct? All the hosts are in this WAF A. Is it clear? Any question? Okay. Now let's check the BGP config, correct? This is all same, right? Neighbor, peer, peering and all. Only difference is here, instead of VLAN base bundle, we are using VLAN aware bundle. What does that mean? For multiple VLANs, you have same RD and RT value. Route distinguisher and route target is same for multiple VLANs, right? Both VLANs 110 and 111, you have same RD and RT value. VLAN base, we used to have 110 separate RDRT and 111 separate RDRT. But here we are using VLAN aware bundle. Okay. Another thing which is added, obviously here we have activated that EVPN neighborship, right? And we have route map to basically to control the routes we should receive or send out. The another new thing is this configuration of WRF, right? So we have VLAN WRF, VLAN basically MAC WRF configuration. Now this is IP WRF configuration. So we have WRF A. It has separate route distinguisher and separate route target, router ID, and we also has redistribute connected. Okay, so this is the new configuration in symmetric IRB. This is not there in asymmetric IRB. Okay, so basically we have WRF and then redistribute connected and separate RD and RT value. Okay. We have used here both 10:10 on in both case, but it can be different. And it's a both are different things. Okay. This need not to be same. Okay. Any question on this? Any question related to configuration? Okay. So now let me show you, so we have ping continuously running, so we can check show IP, show R of all, right? So basically this 10.1.10.1.0.1, which is host H1, right? We have learned the ARP. This is the MAC address of it, BC6D, right? And it is learned locally. So ARP is learned locally for this guy, 110 in VLAN 110. And MAC address is also learned locally, right? So BC6D. So we have MAC also learned locally, right? For this. So we have ARP and MAC learned locally for this. Now what we will do is we will generate type 2 route, right? So let me show you this route when it goes to another site, right? Another VTAP. So when we generate a type 2 route here and it goes to, it is received here at 2A, right? For this IP 10.1.10.1.0.1. So how it will look? Show BGP EVPN route type MAC IP. We want to check this particular route detail. Okay. So basically this is the MAC plus IP route, right? Type 2 route, which has MAC plus IP address. Okay. ARP route. Route distinguisher is your originator VTAP 1's RD value, right? It is received from, this is the spine. Basically, this is our VTAP IP and this is the spine, right? And if you see here route target, right? This route target is WRF route target. So we have two route target, right? So it is this route target 10.10 under WRF. So basically we are receiving route target. Basically based on that, we will understand that this is part of this route, basically WRF A, right? WRF A, this route. Origin, tunnel encapsulation VXLAN, and this is the router MAC. So this is the MAC of the VTAP 1, right? System, MLAC system ID. So this is the MAC of VTAP 1, which is nothing but this VTAP, a system of this MLAC system ID, right? That is the MAC. VNI. So there are two VNI, right? This 10110 is VNI of L2 VLAN 110 VNI, right? So if you remember, show run interface VX1, right? Okay, yeah, we have to check this here VNI, right? So 110.110 VLAN 110 VNI, right? So we are getting VNI that is 110 VLAN and also VNI 10, which is nothing but our this VNI, WRF VNI. Why? Oh, VNI 10, right? Yes. So VNI 10 is this WRF VNI. Okay. So as we discussed here, we have L3 VNI, correct? And L2 VNI. So both VNI will be there in the update message. L2 VNI and L3 VNI. Ethernet segment identifier is 0 because it's not multi-home, right? It's a MLAC peer, correct? So we have this MAC and ARP information, route distinguisher, and VNI, both the VNI, right? And route target. So we have IP WRF route target. So this 1010, which is nothing but route target of IP WRF. Okay. And then router MAC extended community is router MAC. So this is also we are receiving, right? So now we are receiving this route, right? All this information. This is in which VLAN? 10110. This VNI 10110. Do we have locally this VNI? No, right? Or SVI 10110? No. This is VLAN 110. We don't have SVI here, right? So we can't update R, right? So we received this information. This information can be useful two-way. Either if we have local SVI here, VLAN 110, then we will install this as a ARP, right? We can install this as a ARP. But as we don't have this SVI local, we will install this as a route update. So we can check show IP route WRF all, right? Let's do WRF all. So as you see here, 10.1.10.101/32, right? What we received the route for this, we have installed it as /32 route, correct? Let me run that command again. That we have. Yes. So we received this 10.1.10.101/32 route, okay? From which VTAP 254.3. So this is the VTAP IP address, right? From which is nothing but this VTAP in our case. We leave 1A, both of this, right? So that is 2543 VTAP IP address. What is the VNI? VNI 10 means WRF, right? Which WRF we have received this. So VNI 10. What is the router MAC of that VTAP 1? So this is the router MAC, right? This is the router MAC we have received, correct? And local interface on VXLAN 1. So basically, based on this information, what we receive, we have populated this routing table. Okay. Any question? Are you following?
Yeah. So that means for every post, we would need to learn that route.
/32 route. Yes.
Yeah. Okay. Do we run into limitation of the
yes, we can run, because if you have 100K 1000 route host, instead of ARP, now you are learning route /32. Okay, but the advantage is MAC you are not learning. So MAC table exhaustion is not the problem with this. And also VNI, you have only VNI, right? For the VLAN you have local, right? You don't have show run interface VXLAN 1. You don't have to configure VNI for VLAN 110 and 111, right? Which is not local. So basically, symmetric advantages, VLAN to VNI is limited. MAC you don't have to learn. Obviously, yeah. Instead of ARP, you will learn the routes. And also on each router, you don't have SVI of all the VLANs, right? Only specific SVIs. Okay. Any question? Any other doubt? Or if you have not understood this, because this is very important.
For this route, for this /32 route, we should have ECMP, right? In the BGP table, if we enable it.
But you have only one VTAP IP, right? You have to send, because for both of them, it's same VTAP IP, right?
Yeah.
We share common VTAP.
Yeah, but from the underlay.
Correct. So it will be ECMP. So basically, when you check, route for this 254.3, it will have ECMP the way how we received it, right?
Okay.
So it will have two spines, basically.
3, 1 and 2.
Spine 1 and spine 2, like this. So it can have spine 1 and 2. Okay.
Yeah.
Okay. Any other questions? So if you see 254.3, right? See, this is the VTAP IP, correct? Next hop is this, only one. Yeah. But when you check the route to send the packet to your next hop, right? Recursive routing, you will find that 254.3 to send packet, you have two routes, two spines.
Yes.
Okay. Okay. Any other question? Can you tell me, see, okay, so when we install this route, right? We install this route, we use VNI 10, right? VNI 10. Okay, we use all the information. See, route target, VNI 10, and router map, right? And obviously, you know, this /32 route. And this is the next stop. Why are we sending L2 VNI as well? So if you look at here, right, we are sending L2 VNI and L3 VNI both, right? But if you see here, we are using only L3 VNI in routing table, right? We are not using this VNI. So what is the purpose of sending both VNI? Have you got my question? See, as per this packet, we are sending both the VNIs, right? L2 VNI and L3 VNI. L2 VNI is means VLAN WRF, VLAN 10 VNI, 110 VNI, and L3 VNI is WRF A VNI, right? Why we need, and basically if you see, we are using right now to install the route, we are using only L3 VNI, WRF VNI. We are not using this. Then why are we sending this in route update? Is the question clear?
Yeah.
Okay. So anyone knows why we need to send this, or what is the use case of this, right? Okay. Now tell me one thing. When you send, right, when this, see, when this VTAP send this type 2 information, does he knows that other VTAP, right? Say there can be another VTAP pair here, right? VTAP pair here, which has SVI 110 present here locally. What will happen when this type 2 route goes here?
Yeah, that we can install based on the.
Because this guy doesn't know, right, what are the VTAPs and whether they are fully symmetric, asymmetric, this SVI 110 is present on another VTAP or not. It does not know, right? When this type 2 update goes to another VTAP, which has SVI 110, what will it do? With type 2 information.
It will update the ARP and MAC.
ARP table, right? ARP and MAC table, right? And
Yeah.
to update ARP table, it has to know that this route update belongs to which VLAN, right?
Yes.
Correct. So, so VLAN 110 and this IP address, right? 10.101. So it has to know which VLAN this update belongs to, right? And that's why we are sending this both VNI. This VNI will tell the other side that, hey, this update, ARP update belongs to this VLAN 110. So if you want to update ARP table, you need this VLAN information, VNI information 110, which you will get from here. So to update ARP, you don't need this. But if you want to update, you don't have SVI local, then you have to update route, and then you need VNI 10, right? And you don't need this. So basically this both are, you know, depending on your use case, either of this will be used, right? Another reason is this is VLAN aware. So for VLAN 110 and 111, your route target is same. Your route target, obviously, currently route target is your IP WRF only, right? So there is no separate route target we are sending for L2 VLAN specific, correct? So that's why basically you need we send both of this information. If you have other VTAP has SVI for that VLAN, it will also install it in ARP, right? But if it does not have SVI, then it will install as a /32 route. Is it clear?
Yeah.
Okay. Yeah. So basically, yeah, you need to know, right, what is the use case of each of this field, right, which we have added. Okay. So let me show you the packet capture, right, how packet capture will look like. So assume that you're, the same route, right, 10.1.10.101, same host route. We are sending this 10.1.10.101. We are sending out type 2 update message, right? So again, if you go through path attribute, all the BGP, right? AS path, local preference, and all that. Under MP reachability NLRI, we have layer 2 FE-SAFI, right? Which we have FE-SAFI top of that, right? And then we have route distinguisher, RD value, right? RD Ethernet segment identifier is 0 because it's a MLAC pair, not multi-home. Now, if you see here, we have Ethernet tag ID, right, which is 10110. This used to be 0. If you remember the previous packet captures, but now it is Ethernet tag ID is some number 10110. Why? Because now we are using VLAN aware bundle, and in VLAN aware bundle we also send Ethernet tag ID, right? And VLAN base bundle, this is 0. This is the MAC address of that host 1, and this is the IP address of that host 1. This MAC is different because every time when this is the old packet capture, and every time I spin up the host, it will have generate different MAC, right? So just don't go with this MAC, that is different. And this is the IP address. So this is our ARP information. As we discussed, we will send both the VNI 10110. This is VLAN VNI, and this is WRF AVPNI, right? So we are sending both the VNIs, right? Now let's go to extended community attributes, right? So we are sending route target 1010. So that is nothing but IP WRF route target, right? This 1010. Original route origin, encapsulation, VXLAN encapsulation, and router MAC. That is the VTAP1 MLAC system ID, right? So that's what we are sending, which is nothing but MLAC system ID of this. So this is the packet capture. Okay. Any question? Okay. So yeah, that's how it looks like. Type 2 route are advertised. Okay. So this is what, as we discussed, based on all the information, right, what we received here, we will generate type 2 route with all this information, VTAP, VNI, and router MAC. Okay.
So in this case, right, in case of symmetric, we don't need a type 3 route.
Type 3 route, right? What do you think?
I don't think we would need it because that's just for the bump traffic, right? In this case, the ARP and all are not being exchanged because VLANs are not being extended.
Correct, but what do you think? Is there not a possibility? Okay, first of all, you don't know. So VTAP1, when you configure anything, right? All the configuration related to this to VTAP, do you know that this is asymmetric or symmetric IRB? No, right?
No.
VTAP1 doesn't know, or we are not defining anywhere. So first of all, basically, you have to make sure, you have to consider it, or when you implementing this, you have to consider that this is a mixed environment. It can be mixed environment or asymmetric or symmetric, right? So it is possible that same VLAN has host here somewhere or somewhere down 110, right? Host. So that is one. So that's why you need basically, this IMET route, type 3 route. Okay, so that is one. What? Okay. Otherwise, generally, unknown unicast also is not going to be there. But still, if you somehow don't, I'm just checking if do we really don't need that.
In case of pure symmetric like this topology.
Yeah, pure symmetric. Yeah, that's what I am just checking that. See, obviously, as per our implementation, we are going to send type 3 and all, also are going to update the flood VTAP list and all that stuff, right? So that is obviously there. But I am just checking if there is any need in any condition, right? So if it is
But
pure symmetric.
In this case, again, the flood VTAP, like I have VLAN 11 on the first pair and VLAN 12. So the
Right.
flood VTAP, like, do not like.
Correct. Yeah. So here, basically, your flood list is not going to use, right? Because you don't have this VLAN anywhere else.
Yeah.
But so basically, you are right. If it is pure symmetric, right? We might not use this because BUM traffic is because your VLAN is not extended, right? So you are not going to use this. That's right. But generally, if you think about production networks, it will be mixed, right? It will not be pure symmetric. So that is another case. But yeah, basically, we will have this also. But it might not use in a pure symmetric. That's right. Point. Okay. So that was good point, right? That we might not use this in pure symmetric. So now the one more thing is, if you have noticed here, the configuration, right? So run sec BGP. So we have configured tenant WAF A, right? Basically, we have configured WAF A and we have done redistribute connected route, right? The way we have redistribute LAN means what? As soon as we LAN any MAC or ARP address, we will generate type 2 route. Okay. What does this mean is redistribute connected means we will generate type 5 route, right? For connected subnets. Okay. So if I have to go to leaf 1A, show IP route WAF all, right? Right now we are all talking about WAF A, right? And this redistribute connected also is configured under WAF A, right? So all these routes, right? Connected routes, we will generate type 5 route, okay? For this subnets because of that configuration. Redistribute connected for this WAF. So under this WAF, whatever connected route are there, we will generate type 5 route because this is IP prefix, right? So if you see EVPN route type, IP prefix, and this, right? Okay, IP prefix, then we need to give IPv4, then this. IPv4 detail. Okay. So as you see, we have generated type 5 route 10.1.10.0/24, right? What are the field in type 4? So route target, IP WAF route target, VXLAN EVPN router MAC, right? And VNI, which is only L3 VNI, right? We don't need L2 VNI in type 5 route. If you remember the type 5, that field. So basically we are generating type 5 route, right? And if we go back and on this guy, we can check route for 10.1.10.0/24, right? This one. 10.1.10.0/24 VTEP, that VTEP I has sent, right? VTEP1 has sent that route with router MAC and VNI information. So basically, for the same subnet, right, you are receiving /32 route, that is type 2 update message. Based on this, you will install this route, and based on type 5 update, you also will install this route /24 route into your routing table. Okay, so basically you will get two routes for same subnet /32 and /24, type 2 route and type 5 route, based on that. Okay, we'll discuss on this more. Maybe next time we'll compare, with packet capture as well as type 5 format, right? Type 5 this format of, so there we can compare that. Yeah, that's also any question. Any question if you have not understood any of this? Okay, in that case, I think we can stop today.